All right, so taking a look at these problems, this is practice and review from yesterday's work where we learned how to convert between degrees and radians. Remember the general formula that we learned yesterday. This should be from your notes. We have d over 360 equals r over 2 pi, which we can remember by knowing that there's 360 degrees in a circle or 2 pi radians in a circle. And so you notice the degrees are with the degrees and the radians are with the radians. Whole circle on the bottom. And we're just going to be using that to actually do the work. Now, I'm actually going to run through the top two here, and then I'll give you a little bit more time to work on the bottom two from there. All right, so in this case, at 780 degrees, I know that that is my d value, because that's the amount of degrees. So I do 780 over 360 equals r over 2 pi. And then we cross multiply. So I'm going to do 360 times r, which of course is just going to be 360r, equals, and now we do 780 times 2 pi. So in doing that, we do 780 times 2. So we get 1,560 pi. Then I'm still trying to solve this for r. So we go ahead and divide both sides by 360. And so we have r equals, now I'm going to go ahead and write this out the long way first, 1560 pi over 360, and then I'm reducing that. And so I just reduce the fraction. I know that when I reduce my fraction that I'm going to be left with a pi in the top. It's just a matter of how the 1560 over the 360 reduces. Well, they both end in 0, so I know I can divide them by 10, which would leave me with 156 over 36. But then we still have to see what I can divide everything on top and bottom by. Well, 6 goes in. Okay, anything else?
12.
So like if I divide it by the 10 and then the 6, that would give me 26 over 6. So you notice actually we can keep going with that. 26 and 6, I can divide them both by 2. And so then we end up getting 13 over 3. So that's our radian value, 13 pi over 3. So for the second problem, I do the same kind of formula. I'm going to do the d over 360, but in this case I don't know what d is, so I do d over 360 equals r over 2 pi. But in this case, I know what r is. R is the 11 pi over 6. And then we cross multiply. Now when we cross multiply, that means I'm doing 360 times 11 pi over 6. So do 360 times 11, divide it by 6. And that gives us 660 pi equals, then I cross multiply the other way, so I'm going to do the d times 2 pi. I'll call that 2 pi d. And then I need to solve this for d now. So in order to solve this for d, I'm going to divide both sides by 2 pi. And when we do that, 660 divided by 2 gives me 330. And the pi divided by pi, those cancel each other out. And so it's just 330 on the left-hand side, and that will equal d. Therefore, my answer is 330 degrees. And then when we go to cross multiply on this one, this is where sometimes people get a little hung up. And I'm doing 360 times pi over 6. But remember, if I'm multiplying 360 by a fraction, I multiply it by the top and then divide by the bottom of the fraction. So 360 times pi is going to be 360 pi divided by 60. Well, 360 divided by 60 is just 6. So that's why that's going to end up being 6 pi. And then when we do the rest of the work, we should be getting an answer here of 3 degrees for pi over 60. So in last night's assignment, you filled in all of these radian values. And so those are hopefully all correct now. Now, it could take a long time to fill all of those in if every single time we had to use that formula. So I want to talk about how we can know some of these values without having to do the formula every time. And it's also going to help us to be able to fill these values in on the unit circle quickly and from memory. So just focusing on the angles here, there's really only a few angles that you have to know here, either by heart or by calculation. I would definitely say you need to know that 0 degrees is the same thing as 0 radians. But then if we do calculations or do the work or remember whatever it is, to remember the pi over 6 and the pi over 4, you're actually going to be good for finding everything else just from those values. Let's take a look and see why. So 60 degrees. Notice 60 degrees is double 30 degrees. And so the radian value is also going to double. So I could take my value from 30 degrees, which was pi over 6, and I can double it. So I could write it as 2 pi over 6. And notice what 2 pi over 6 equals. That equals pi over 3. 90 degrees. Well, that's just taking 30 degrees and multiplying it by 3, right? So I could write that as 3 pi over 6, which you notice reduces to pi over 2. And I could keep doing that for all of the 30-degree intervals. So at 120, that's 4 pi over 6. I got to skip the 135 for the moment. And then at 150, well, of course, that just ends up being 5 pi over 6. It doesn't reduce at all. 180, well, that is 6 times 30. So that's going to be 6 pi over 6, which you'll notice reduces down to pi. And we can keep doing that to get all of those other 30-degree intervals. So I can do that exact same process to find all of those 30-degree intervals. Well, that left us with a few extras that we still have to figure out. Well, for those, you notice all of those are at 45-degree intervals. So getting those, like starting with my 1 pi over 4 here, I could go to 90, 2 pi over 4. 135 is 3 times 45, so it's 3 pi over 4. And then 4 pi over 4, 5 pi over 4, and so on. And so notice all these different patterns that are involved just from knowing those first few values. So if you know those, you're then going to be able to start filling in your unit circle picture, not only all like the sine, cosine, and all that kind of stuff and the degrees, but you also be able to fill in the radian values as well. As you're working on filling this in without notes, I want to check and make sure you got the right starting point, because there are just a few values that if you know them, the rest will flow much more easily from it. First of all, of course, we should know where 0 is, right? And in terms of angles, we should know that it's 30 degrees and 45 degrees here. And we earlier talked about how 30 degrees is pi over 6, which if you forgot, you could use the formula. And 45 degrees is pi over 4. That's all I need to know to fill in the rest of the angles.
No.
And then for the sines and cosines, we do have to remember there. Sine. Which one's sine? Is that the x-coordinate or the y-coordinate?
Y-coordinate.
It is the y-coordinate, yes. And cosine, that's our x-coordinate. And so, there's one big critical value that you should know off of these. The sine of 30 degrees is a half. And if you know that one, a lot of other stuff should follow just from that. Then a couple more values that are useful and needed to know. Because I knew that this sine was 1/2, the one that always goes with 1/2 is root 3 over 2, so I would know that that would be the cosine there. Also useful to know is that when we get to the 45 degree mark ones, there. Remember, root 2 over 2 is the critical number to be involved there.
How would you know that's what happened?
All right, so now check all of your answers. Let's see how well you're able to fill it all in just from memory and maybe a calculator here and there.